Okay, so today we're going to learn about, we're just going to keep learning about APIs, which we saw yesterday. We got to make some network requests to those APIs and get some information from there. And we're just going to learn a little bit more about that today. And we're going to see the most common kind of API, which are RESTful API. And we're going to hopefully, by the end, get a little bit of a better sense as to what RESTful means. Before we do that, though, some feedback that I got yesterday, which I really appreciate, was it was really hard to find requests that will return to you certain HTTP response codes. And if I was also asked if I could revisit two of the exercises, which were finding an API that gives you all the songs that have a specific word in it, and I forgot the other one. I could check it out here. Oh. Oh yeah, the GitHub API usage. So I just want to demonstrate those two, which were in the lab from yesterday, which was API intro. So I just wanted to go walk you through these two examples. So one was find all the, well, with GitHub we have a couple. Find all the repos on GitHub with pursuit in their name, right? Another one was find all the GitHub repos that have JavaScript as their language, and the one with the song was a list of all songs with love in their title. So what were some of the first steps as you saw something like this? Let's do this one first. Basically, find an API that will give you songs with love in their title. What was your first thought or your first step for doing this? I mean,
using API that allows search based on content.
What was the first word you used?
Using API.
Use an API. Cool. And even before before we can use it, what do we need to do?
He said music.
Music?
I said music.
Okay, yes. But before we can use it, before we can use that API, what do we need to do? It could look as a trick question. If what will be the more elemental step that we need to do before we can use it? Yeah. Yes, and before that, I think I heard somebody say it, you just have to find it first. Before you can use it, you need to find it because we didn't tell you. The next step will be then read the documentation. And then the third one will be actually use it. So first, one thing we could do is here, as the lab suggested, whatever you're looking for, just put next to that the word API. So I'm looking for a music API. So I'm going to do music API. And then there are some results that I can get. And here, let's look at this. It has the top 7 free music data APIs. They are listed here. Audi, Deezer, iTunes, Spotify, SoundCloud. So from this one, we could look into them and see how we can use them. For some of them will be easier to use than others. Something that I think some of you remember was that in one of the examples in the lessons, we were using the iTunes API to get podcast episodes that had the words Swift plus coffee plus over in their title. So I just remember that I could use that same API, but instead of searching for podcasts, I can search for songs. And that's actually one of the listed ones here. So here I could just get more information about the iTunes API documentation. Where is this? Here we can see like all the options that we have. We can send post requests, search for music, and in fact, I'm gonna just go back to the intro to networking and API. Oh, but the lesson, I need the lesson. I think that might be. Just search it here. I think that was called something like API. API intro. Just so I remember this URL. So here, this was the URL that we were using for getting a podcast episode. So I'm just gonna copy this URL, and I'm gonna change a couple things on it. I'm gonna open Postman. Oh no. Post. And once I have Postman open, I'm just going to copy the URL. And a good thing, a nice little thing that Postman does for you is this stuff that we're seeing here in the URL. After the question mark, I call query parameters. And this is information additional to the URL. That we could use or manipulate to change what that URL is going to give us back. So a good thing that Postman does is that it also fills out this input boxes here with the exact same values from the URL. So instead of editing here, I could just edit here directly. So we can see that this URL is using 2 query parameters. One is a term and another one is a media. The term seems to be like some sort of a keyword that I'm looking for. And in that case, we were getting all podcasts that had titled Swift over coffee. And in here, instead of Swift over coffee, now I want love. And I think I could specify instead of media, I don't want a podcast, I want a song. So I'm gonna check this, see if, now we can see also that in the URL, those change because we changed them here, down here. We have love and media as, love and song as our query parameters. Now I'm gonna hit send and see what happens. Uh-oh. We have a problem. A search string term must be a search string. Love and media song. Music instead. So that means that, let's try. Correct. So that was the actual one. So what does that say about me as a developer trying to use this API? What step didn't I didn't do? Reading the documentation, right? I didn't read the documentation, but somewhere in the documentation it must say that the media must be one of music, podcast, and even more. But when I put song, that was not a valid media type. Therefore, we didn't get what we wanted. We can see that if we look at the track name, this one is called Love, and it's by Nat King Cole. I don't know who that is, etc. Sorry.
Initially, the first link they had pluses in it. What are the pluses do? 10% add some plus space?
Yes, that's correct. So in URLs, if I want to do like love and cats, I cannot really do a space. Let's try this. Actually, this worked. Let's see, Jason. Let's look at Love Cats. There's a song called Love Cats. Oh, that's the artist's name, yeah. So it's somebody's.
What?
Anyway, so, but under the hood, this space here must be converted to either a plus or a %20. These are two ways in which you can express a space in a URL. It's similar to, yes, %20 or a plus. I think, let's see if this breaks. Okay, this still works. Now I have the %20 in the URL here, and we still get the same results. If we do love plus cats, we should still get the same results. But this is all sort of, we don't see it being converted because Postman is just nice and doesn't show us that. If we did that in curl, it would probably not work. Actually, I just want to try it. Copy this. Now go here. Oh, but I think it did work. But that's because my terminal didn't put a space. So maybe I have a misunderstanding of spaces and URLs.
Sometimes we have them, but generally we have pluses.
Spaces and URL. Let's try to settle this. A URL must not contain a literal space. It must either be encoded using percent encoding or a difference coding that uses URL set characters. Application XWW form URL encoded uses the plus instead of the 20. Syntactically, a URL must not contain a literal space, but doesn't say much more. Oh.
Was it trying to say that unless it's encoded that way, it can't have a space?
Say that again?
I think it was trying to say unless it was encoded that way, it can't have the space, and even if it was encoded to the space, it'd be okay.
No, so this is the second paragraph here. Right, it must. What? Mm-hmm.
Takes the place of the space.
Let me try this. I'm gonna do. The problem is that my terminal here is adding some backslashes and stuff. So I'm gonna quote this and see if it still works. I'm gonna quote quote the URL, and then I'm going to remove this part. Not that one. This one we must leave. This one we don't need. And then we have a space over here. Let's see what this gives us. Okay, so we did see that the space is not allowed in the URL. As I quoted, my stuff didn't work anymore. Let's try %20 here. Now we get even better. Oh, I will need a slash for the %. That's correct. Still doesn't work. The backslash. Okay, I think we're going down a rabbit hole. Which one? No, but the term has this one. After, no, I think, let's try a plus. Let's see if it works. Page not found. So there is something that is being applied to the URL that this time I cannot explain. So most commonly, you will see that spaces are replaced by %20 or pluses when you're doing it in URL. Just keep that as a sort of as a side note. Any questions on doing the request here in Postman and with these query parameters? So let me see what happens if I do. So another cool feature of Postman, but you are not encouraged to use just because we're going to learn how to write this, is that you could see the code that makes up this network request and how it could be sent. I don't know why it's, oh, okay. And you can see JavaScript. Let's try rest. So here we can see, wait, do I have, okay, look at that, look at it here. This is what we have in our, we have the actual space in Postman. But when I look sort of behind the scenes, some of the code, if I go here, then we can see here that it's being converted, the lob %20 cats. And we can see that those are part of something that is called the query parameters of the request object. But what I wanted to show you is that here, sort of under the hood, the code that is actually doing this will convert that space to a %20. Okay, so any other questions or comments? Let's do the GitHub one. So I'm gonna only do the one with pursuit in their name. It's find all the repos on GitHub with pursuit and their name. Oh, actually, so I think Douglas we were doing this yesterday. It didn't have to be the pursuit. It didn't have to be the GitHub name, the GitHub repos whose name was under the organization pursuit with their name pursuit. It just meant like general, like find all of them, no matter who the owner is, as long as it has the pursuit part on their name. So for doing this, what's the first step? Fine, and then we could do GitHub space API. And then it seems that this one is good. And what are we looking for? We're looking for repositories. So here I could search here. If I know that I want repositories, I'm going to type repositories here. See what this, oh, repositories, that's one result. Then we get to the repositories section of the GitHub API, and we can see all the stuff that we can do. We can list repos, list user repos, get, edit, disable, list languages, transfer a repo, create a repo. So here what we want is actually search. And that one is not here directly. Let's see if we do list repositories, and let's see if we can specify query parameters that will allow us to search for a specific word in their name. List repositories that the authenticated user has explicit permission. Okay. It seems that the endpoint is user/repos. So these are probably the user will be a placeholder where I need to replace for the actual username for a user. Oh, actually, this seems to be the way. Users, and then when you see this colon space something else, it means that it's a placeholder. It means that this username here must be replaced by an actual username from a user. Well, if we think about it, I don't think this is going to give us the right results because this is searching for repos only under a username, under a specific username. So I have to go back, see what else we have here. Instead of that, instead of repos, let's try to do search. Okay, we have a section that will allow us to search apparently. Search repos, search commits, search code. I think this is the one we need. Let's look at this. Okay, it says that /search repos, search/repositories, and then we can specify some parameters for that. One such parameter is Q. It has to be a string, and it is required. So probably if I skip the Q, it'll probably break or complain saying you didn't specify. The query contains one or more search keywords and qualifiers. Qualifiers allow you to limit your search to specific areas of GitHub. The REST API supports the same qualifiers as github.com. And then it says learn more, and then it says learn more about the format of the query and see constructing a query search. Okay, so what URLs should I put in my Postman to try to use this? I know that this is an endpoint that I could use, but this is not a full URL. A Postman needs a full URL. How do I sort of derive that one? Or where do I find the full URL? Shara?
After this example, below, you can check. Yeah.
Lovely. Always look for the examples. So here we have an example. Suppose you want to search for popular Tetris repositories written in assembly. Wow. The assembly is like the most low-level language that you have to. I think it's the most low level that you can get. So building a game in that must not be fun. So here we have this URL. We see that this is known also as the root URL. So the root URL is this part, GitHub api.github.com search /repositories, and then I have to specify a Q, question mark Q equal Tetris plus language assembly. Okay, I don't really care about the language, so I'm gonna do maybe just this. Copy this, paste it on my Postman. Let's close this on the side. So let's see what this gives us. Wow. So we got a response. It doesn't look like an error. We got 26,656 repos that have the word catchphrase on their name. This is quite a big response. Who knows how many lines of code of JSON this is? Okay, but we're interested only on the ones that have pursuit in their name. So I'm going to change that Q parameter to pursuit. I hit enter, and now we have 1,322. So we can see that somebody called PureScript has a repo called pursuit. What is it about? Description: website for hosting or searching PureScript API documentation. Maybe this is another programming language that we haven't heard of. Cool. And oh, this one is written in Haskell. Questions or comments on using this one API? Yes, Douglas?
Would you use the parameters in post to add another, if you're going to add another value to search for, would you add it to the end, like after pursuit, or would you make another queue key to make another query the same?
That's a good question. So the question is, if I want to pursue, let's say I want all the repos that have pursuit and one, the word one in their name, would we add, the question is, would we add another queue here and then say one in here, or would we add it after the pursuit? To be honest, I don't know the actual answer to that question, so let's just try it out. Let's try this one. Let's do pursuit and then another queue, one. And let's try send. We got even a larger response body. As we can see, now we have, again, no, this time we have 278,000 response objects. So at least it didn't break, so that's a good thing. It didn't give us an error. Now is about understanding what did we get back. What do you guys think? Malik? It included everything with one and in the name. So let's try this one. Open Nebula repo 1. Let's go randomly to 1. This one is OneDrive. So that's correct. Any other, I think to that answer is correct. There is, I think, a twist to that, which is, I think here we have not only repos that have one on it, but also repos that have pursuit on it. Or it's either one, both, or either of them. So here, let's do search for pursuit. Oh, so you can see that I was wrong. We don't have any repo with pursuit in their name. We have only the ones that have one. I initially thought it would give us both, maybe the ones with pursuit and one, or either of them, and it doesn't do that. Douglas?
I think it might only grab the queue, the latest one, the one at the very end of it's only giving you the search of one, and it's everything after that queue tag. So it sort of ignores the one before.
Let's verify that. Let's add another one. Let's call this one 3. Send. We got 3 here. Did we get pursuit, or did we get 1? We got some 1s, but it's not guaranteed that it's in their name. Is this, okay, so let's search by something that has name. So we got We get repos that have their name be 3, something containing the word 3 in it, but we don't have one with the word 1 in it. So that's correct. It takes the last Q that you specify. So if we wanted to look for repos that had pursuit 1 and 3 in their name, we'll probably need to specify them here. 1 and 3. Let's remove these ones. Let's see if by any chance there is something like this. Yep, we got 2. 2 repos have this combination of words, I guess. Oh, actually, no. This one is Boeing. This is like a plane, I think. Yeah, an American all-metal production. For some reason, there is a repo about a plane. Say that again? Oh, it uses pursuit in the description? Nice. And then it must also use 1 somewhere. 1, and then it must also use 3. Huh, that's interesting. Sorry.
Can you check if you get 3 Qs or put ampersand between them?
An ampersand between them.
Yeah, so see what we for multiple things.
I see where you're going. Yeah, let's try that one next. But we can see here that then this Q is searching not only in their name, it's searching in their description too. That's something that we might want to watch out for. So Shara's suggestion is, I think he already saw how we could combine multiple query parameters and it's with an ampersand. So his suggestion is, let's try this again. Q1, Q3, but we're already putting an ampersand here. If you look at it here, so this was what you were suggesting, adding the Qs with an ampersand. That's another thing that I forgot to mention. Query parameters will be, if you have more than 1, they must have an ampersand in between them. That says, it's sort of this ampersand is sort of using the meaning and, which is the regular meaning that is used on. So query equal pursuit and query equal 1. And in the case that we had before was term equal love and media equal podcast. Cool. Any other questions before we transition to RESTful APIs? Yes.
Just saying, you can also make it specifically target user names. So you can put there. Is that the search users?
You mean instead of searching like repos, I could search users?
Yeah, so it's more specific to the actual user.
Mm-hmm. Yeah, and we're gonna see actually today why that is good to have. Why it's good to have this sort of hierarchical model for information, where you can only search not only repositories, but also if I change this to users, it'll probably have the similar effect. Let's try this one right up quick. Q pursuit. Yep. There we are. I think this is us. Oh, this is not us.
You can put slash then the name of the user.
Mm-hmm. Oh, here I guess it's searching for. Actually, their username is pursuit. Oh, but the thing is that we are join pursuit. Join pursuit. This is us.
Yep.
There we are. Cool. Okay. So any others before we move? We're just gonna be like seeing more APIs, which is this stuff that we're seeing here. Stefan?
I was wondering, is this taking care of all the people who may come with pursuit on their name, right? But then there's another one that says all the jobs are focused on pursuit in their name. But we just put JavaScript
So let's look at that one. So let's say you want to search for all the repositories that have pursuit. We realize that this is not only in their name, but also in their description. And I think it's possible that is even in their README, but we'll need to read more of the documentation to back up that claim. If we wanted to like sort of filter down this list so that we get not only the repos that have pursuit somewhere in their name or description, but also are from a specific language, we'll need to read the documentation. And in that documentation, it said something about. So we have these parameters: queue, sort, and order. We don't care about these two. There is constructing a search query link that we should look at. And then here is an example. For instance, queue search keyword plus search keyword n plus search qualifier 1 plus qualifier n. So look at, this is actually already telling us that if we want to look for multiple keywords, we'll need to put a plus in between them. And then there is this option, qualify 1. And you may wonder, how is a qualifier different from a keyword? Let's look at this. Let's look at this example. For example, if you wanted to search all repositories owned by defunct that contain the word GitHub and AutoCAD in the README file, also you see this is also being searched in the README, not only their name, but also their README. You would use the following query with the search repositories endpoint. And then we can see here that these are the search keywords, GitHub and AutoCAD. And then we have this weird thing that we might have not seen before. It says in README plus user colon defunct. So this is what they mean by a qualifier. And qualifiers are ways in which you can search in GitHub. For instance, I could do here, I think I could do user Alejo 43. And then I want to search all the repos that have hello, if I may have one. Actually, I think I should have put this into one. But this is searching also in the code. Yeah, you can see that this syntax, this qualifier, this is only in GitHub and maybe some others, but not all of the APIs will give you this search, this way of querying to specify, I want the user, I want results only by this user. Also, this is something that works in Slack as well. If I want to search for a message from JR, I could go here, and I could type from, and then the JR's name, and this gives me all the messages by JR. So this is a really nice way of searching, but don't rely on all the APIs providing you with this way of searching. Only the really nice ones will give you that. But here is like, I can search by just specifying from and then that. So it turns out that here we can see that we tried this in here and we gave me all the, wherever hello appears, not only, well in this case I'm searching across even code, but that are only my username. This is my username. So this is all the code where it says somewhere hello. So what we want to do for specifying the language that we want JavaScript is use a qualifier. So let's do GitHub qualifiers. Let's see if we can find anything here. Searching for repositories, searching for code. Let's command F, qualifier. For a list of search syntaxes that you can add to any search qualifier to further improve your results, see understanding search syntax, I think. And then this is all about, reading the documentation. This document says understanding the search syntax. Seems that you could even specify how many stars the repo has. That's really cool. We could use dates for when a line of code was written, but these are all I've never used any one of these. Actually, this is the first time that I'm seeing this page. But somewhere here, we can see where does it specify query for dates, query for value greater than. So it must be this one, qualifier. Another way you can narrow down your search result is to exclude certain subsets. Oh no, that's the one above. You can prefix any search qualifier with a dash. Okay, yeah, so that's because that's the not. Label. So actually, I don't think this is the one that we want. Let's look at all. Put this here. Searching code. I want to see if we can find a list that has all of them. Let's look at this, search by language, which is basically what we want. Okay, here we found, I guess these are all the qualifiers. I was just not looking at them. Here. We have these qualifiers, in, and we can specify a file, or in and path. User, this is the one that I use, username, org name, repo, and one of them is language. This is the one that we need to use to find all the repos that have pursuit somewhere in their description or name, and specify a language. So now with that acquire, with this knowledge acquired, then I can just go here and type plus, because I need a separator, language, colon, JavaScript. Let's see if this works. Now we have 142, and we have this repo called Argo. That is, the language must be JavaScript. Language is JavaScript, correct. And then somewhere in their description, it has the word pursuit. The quest in pursuit of the golden fleece in Forex chaos. So that's how we could use this qualifier language to narrow down our search. Cool. Questions or comments? You could say that this is not the correct answer for the question, because this is searching both the description and probably also it's not searching the README. But for only searching in the name, we could just try to find in the documentation maybe another qualifier that will allow us to search only by that repo name. Cool. Okay, let's take a 5-minute break to get into today's topic.
The name,
Say that again?
you would have to include another qualifier.
Yeah.
So qualifier
So let's look at here. No. It was not here, not here, not here, not here, here. Maybe if I search for name, file name.
Because the query will be pursued. The qualifier with the language. I mean, yeah, the language, and then for the name.
So actually, I'll need to do a repo.
Just be the query.
No, because the query, the queue is searching in their name and also their description. So the question was, oh, I already
All the
closed.
JavaScript repo in GitHub with pursue name.
Yeah, all the JavaScript repo on GitHub with pursuit in their name. So we don't want pursuit anywhere else, but pursuit must appear in their name.
As in the JavaScript files.
No, in here, in this part. Pursuit must appear in this. This is the repo name.
For a specific file that is language JavaScript.
Oh no, not a specific file, a specific repo. So you can see here.
I mean, a specific repo that is using the language JavaScript.
Correct. Yes, that is the perfect way to describe it.
That at the moment we only have the repo that says pursue because we put the query pursue, right? But then you specify the qualifier, which is language. How is it that's still not correct, right? Because it has no name of that.
Oh, because the result that we got here. Oh, did I close it? Yes, I closed it. The result that we got here, it didn't have pursuit in their name. It had pursuit in their description. But the question is asking for pursuit in their name.
So what do we have to add?
Another qualifier.
Qualifier in this case is language, JavaScript.
Yes.
So
But
what would the qualifier for that specific name? Would be just pursue?
it will be, so this will give us all, I think this will give us all the repos that have JavaScript, their language. Yes, so here I'll need to do plus and then another qualifier, and I only want in their name to be, so I think that other qualifier could be repo. Oh, it's not here. Oh, it's the other way around. Matches code from Mozilla. But I need to specify the username.
So, but to specify it for name, like it has its own specific way as well. Like the qualifier for the language was language, and for the pursuit was a curry.
Yeah.
Cube. And then for the specific name, which is again pursuit. But of the repo, right? That's the name of the. No, that's the name of the. What's the name of what? I'm confused now.
Let's try this. Repo. Pursuit.
It's like if you use names. Validation. That supports
Let's try this. Okay, what if I do? So this will find them. So this, let's see if this is giving us the same result. But it's giving us this one.
The repos are specifically made for, so that's what we did before, right? That was a query. And then the only difference would be adding the language would be the JavaScript. But wouldn't all of that, everything we just said wouldn't be covering all the bases.
So this is combining here. Once we add the qualifier for the language, we're looking for
the language, right?
For the language, no, we're looking for both the language and pursuit. But the problem is that pursuit will be here, for instance. This is not in the name of the repo. But you will need to like dig down more in the documentation to find how to actually narrow it down to only their name. So for instance, this will be a valid result. Almost everything else will be a valid result. Because everything else has pursuit in their name.
But when we, you know how we manually just type that into the link? Like, to have that, like, what would you do? Like, that's like...
The documentation must have a way that I just don't know yet. But if I read more of the documentation, I'm pretty sure.
You keep going around it. You keep going around like, okay, it's still not answering my question. I get
well, yeah, I mean, I don't.
Put it into question. I know I have to use the rest.
Okay. Okay, let's get back to it. So today we're going to talk about REST APIs. So we're going to be talking about REST APIs today, and REST at its core is just a set of rules that define how we should use the HTTP protocol to interact with an API. So REST at its core is a set of rules with which that we should follow to correctly use the HTTP protocol. And us, as not only for us to use as consumers of those APIs, but once we start creating our own APIs and our own servers, we want to make sure that we're respecting the REST rules. Also, like the more technical name is, REST is a architecture. It's somewhere in here. We must have, yeah. So that's architectural style. It's an idea that gives us an architectural style that is the most common use in the web. And what do you think architectural style means? We could put that in more common words. Maybe an analogy or an example. What do you think architectural style means? Hugo? Correct. Basically, that something is built. The way that something is built. That's correct. And so, for instance, when we were using the dog API, the way that the dog API was built was so that when you do, let's go back here. Say API. Oops. Here, the way that this one was built is so that we have some sort of a hierarchy where we have the API, and then under the API we have breeds. That means that maybe we not only have breeds, maybe we had other endpoints here, other sections for this piece of the URL. And then after that, we have image. So maybe we can get more information about the bridge that might not necessarily be an image. And lastly, one random. So this is another piece of that architectural style that they decided to implement. So that information is sort of in this hierarchical way. And most commonly, we want this hierarchical way because it just makes sense. It's to keep sort of information in this way. Another example of that is the DOM. The DOM itself is a hierarchy where we have another div and that has child, and then that div might also have grandchild because the child have inside other child. So that's one of the core concepts of a REST API. And I say that we want to use the HTTP, so the REST idea, or more properly named architectural style, also dictates that we should use certain HTTP methods for their corresponding actions. So this is something that we're going to see in a few minutes, but it turns out that so far the requests that we've made are GET requests. And they're called GET requests. Why do you think they're called GET requests? There's two main reasons that I can figure out. Maybe one is more obscure than the other one. But let's talk it in sort of everyday language. Yes, Manuel?
It gets from the API into your software.
Correct. It gets information. That's at its core. It gets information. Another word for getting is also reading. So you can say it gets information or reads information. And then the other one will be that under the hood, the request itself has a method called get, and that's what it makes it a get request. Not only that it's getting information, but that the request under the hood has a get method. I believe we could look at it. Well, here we can look at it here because we have this nice little interface here, and these are all the HTTP methods that you can use. Here we're gonna see like the top 5. Also, let's see if I can show you here sort of the code under the hood here. So this is what a network request looks like raw. Basically, this would be what it looks like if we could see curl's request. Here we see a bunch of apparently random information. One thing that is good is that first we have the method is always the first thing. Here we have it all in capital letters. That's another standard. Methods will always be in capital letters. Here we have the get, and then we have a URL. Actually, in here we see that we don't have a full URL. We have an endpoint, and this endpoint will be appended after the host. So the host is this section of the URL that has the .com part. That's what we call the host. But important here is this get. If I change this here to something else, and I inspect the code here in the HTTP version, like the raw, now we see that the method is different. And so the REST also says that you should use the right methods for the right task. So why do you think we will have different methods for HTTP requests? What do you think is the motivation behind that? Think about that. Think about that for 30 seconds. I'm going to call randomly on somebody, and we just want to hear what you think about it. Like, why would we have different methods to use in HTTP requests? Wait. I forgot what I have your names. Okay, let's see. Oh, that was not. Peter.
I assume they all do different things.
All do different things. And what do you think? How are those things going to be different? What do you think? Just you can speculate. Like, what do you think is the difference between a post and a get, as the two that we have seen?
A post, maybe you had a website like Facebook, and you want to make status, you would use like post.
Mm-hmm. That's correct. Yeah, that's so that there tells us that post sounds like when we're posting new information. And here, I think in the notes we also want to make the difference between, well, post as the verb means that something is being sort of published, right? So it doesn't necessarily. I don't want you to also associate post, the request method, with Facebook post or a Twitter post. Those are actually indeed being made by post request. But I could also add a new to-do to my to-do app with a post request. Post just means like new information is being added. And that's correct. Different methods are used for different things. And they have fairly simple names: put, patch, and delete. What do you think patch will do? What are some of the stuff in real life that you do patch? I actually my mom patched one of my sweatpants, and I really like those sweatpants because now they're special. Yes, Joy. Update, correct. Or fix. We'll use patch for that. Delete for self-explanatory. And put, there is one article that you should read after this lecture, which is put versus patch. It turns out that put can also update, but patch will update like partial information. Put, if you want to update with put, you want to repeat the original information and then change the one that you wanted to change, but you will need to include the original information too. We're going to get to revisit this again. So what's REST? What is REST at its core? A structural style, a way in which we make APIs. Okay, so the RESTful APIs have these principles, which is uniform interface. And that means what we were talking about, like using the proper methods for the proper actions, not mixing them. For instance, like it will be wrong, even though it's possible, it will be wrong to use a GET request to add a new to-do to my to-do list app. I could do that with a GET request, but the problem is that, well, that I'm not respecting the standard, I'm not respecting the REST principles. A GET request with the method GET should only be used for retrieving information, right? Not to add new information. So we don't want to mix. The hierarchy that we were talking about earlier, that makes it a uniform interface where you could even, in some points, as we saw in the GitHub API, we could start to speculate as to, because this is sort of predictable in that hierarchy, we could start to guess what other things might be there. That's just because the developers, the creators of the Dog API and the GitHub API decided to have a uniform interface. Cool. Questions or comments so far? So you want a uniform API. What would be a not uniform API? What do you think? So what we just said. Would it be easier to figure out stuff and assume stuff, it won't be easy, right? It might not follow the right HTTP methods for their corresponding actions. They might be patching a resource, patching a document with a post request, or deleting a document or a to-do with a GET request, right? That will be not uniform. Another principle is client-server. So client-server, this principle means you want to separate your concerns. And this is something that not only applies in this context, similar to when we were building the Hangman game, or the Hangman game, we want to have one function do one thing, right? And we want one function to take care of getting the random word, and another function to take care of updating the character in the word. So this is similar here, where we want the server to do one thing, which is take care of the storing the information and handling the information, and the client be taking care of what that information looks like once the user visits the page. And so that this, the cool thing about this is that since if we separate the concerns, then they can evolve separately. So that if I have, in this example, I got a new eraser, but I didn't bring it. But in this example where we have these two apps, because they're separate things, I could add a new feature on the server without having to modify any of the client code. In fact, the client might not even be mine, and the opposite is true as well. The server might not even be mine. But let's say I'm coding the client, which is how we start. We actually start here in this course. We start writing sort of client applications. The APIs are not us and not ours, but we're going to get to build them. So, for instance, the developers of the dog API could add a new route, a new endpoint, and they didn't have to touch our client code because they are separate separate concerns. That's just another principle that we should respect, that separation of concerns. It turns out that in the beginning, you'll build an app and you'll build it all together. You'll build like a server, and this server also took care of the HTML, the CSS, everything will be basically just one app. The problem is that if something changes in the server, you may need to change code in your HTML, or vice versa. If something changes in the HTML, then you may need to change some code in your server as well. So yeah, like those are what we'll call like monolith apps, and they are very sort of rare nowadays. That is just like one app having everything inside. So the most common, the way that we're going to be doing it here is separating those two concerns into a server and a client, and there basically will be two separate apps that and that allows to evolve them separately. In fact, so separately that let's say for your capstone project, something that we did was I was more into backend development, so I asked my team to be able to work in the backend. So I took some of the backend with one of my peers, and the other two people took the front end. We still had to jump in between them, but this separation of concerns allowed us to work somehow independently. Right? Questions on client server? Stateless. This one is somewhat obscure. Let's see if we can make sense of it. So it turns out that the HTTP protocol is by default stateless. And what that means is no information is saved in that transmission of data, or not in the protocol. Like the protocol, let's just do, so let me actually see what I have here. Okay, so one example is that every request to a server is, a server will look at your request and it will not know if you did that request 2 seconds ago, or what you want to do with that. Basically, the server has no outside context, has no context as to what you're making that request for, or what you're going to do next as the consumer of that API. And for the server, all requests are sort of like new. All requests will be, let's say, one example could be, let's say the dog API. I make this network request to this random dog, and then let's say the next request I make it to the breed list. Actually, this is not a good example. But let's say even like how a good example could be how you have to log in for a website, right? You have to log in, and the system seems to remember you. If you don't log out and you go back in, the system seems to remember you. That way in which it can remember you, something that was added, and those are the cookies basically that we have briefly touched upon here. But that cookie that has information that identifies you has to travel with every request to the server. That is again like I hope maybe by contrast can demonstrate that the HTTP the HTTP protocol doesn't know who you are. The server will not know who you are unless you have that cookie with you. So that's so that by contrast, we realize that if we don't have that cookie, then the server has no way to remember us. It's stateless. It doesn't know who you are or what you're going to do with the information or what you're going to do next. All information that, another way to put it is, all the information that the server needs to fulfill your request must be in the request body. For that, I guess one example could be, let's say I'm building an app to take notes, and my app I can create books. I could create, what do you call a book where you put notes, a notebook? Let's say you can create notebooks in this app, and then you can put notes in the notebooks. Suzette is still laughing. So yeah, imagine we can create an app that allows to take notes, and we can create notebooks in them and associate a note with a notebook, right? So we could have a request, we could make a request that creates a new notebook. Let's say I'm going to call my notebook journal. And then the next request, I want to add a new note to that notebook. If in my request, I need to specify to what notebook I want to add the note to, because the server is stateless. It doesn't know all the information that it needs to fulfill your request needs to be in the body. So, and that example will be, let's see if we can demonstrate it here. Let's say I have my API notebook. And to here, because I want to create a new notebook, I'm going to use post. Let's say I can specify here the name. And it's going to be called journal. Just bear with me for a second. So this will create, this will create a notebook in our API called journal. Now you could think that, okay, the next request that I can do will be my API, maybe instead of notebook, note. and then maybe instead of name, we're gonna do the text. I went to the beach. This is the content of my note. The thing is, because HTTP is stateless, and every request to the server is as if it was a new request. The server doesn't have any context. If I send these requests like this, my server will not know to what notebook to add my note, because it doesn't know that I created a notebook right before. It will not remember that kind of stuff. So if I try to do this, my server will probably respond back saying, I don't know what notebook do you want me to add this note to. So again, what I said is the request will have to have all the information required to fulfill, for the server to fulfill the request. And in this case, what is the other piece of information that we need to make this a successful request? What do you think? Because this server doesn't know that I created a notebook. 200? What did you say? Oh. So I'm just like, here I'm trying to add a note to my notebook, the journal notebook. And I want that note to have, I went to the beach. So I'm saying that every request, because the protocol, HTTP and REST also suggest for you to not have any state, for not have remembering stuff in the server in a way that will allow us to associate this note with my notebook. What I will need to do is, what do you think I need to do here? Like in here, my so the server that is saving stress is that this note, by me doing this and hitting enter, it is saving this note. Right? First, I created a notebook, and the server saved that to the database. And then the server saw an incoming request to create a notebook. It did create a notebook. After that, it saw an incoming request to fulfill this. So that's basically what states. And it's sort of abstract. I think by the end, I think by the end you'll have a better understanding as to what this means. Yeah, I remember that when I first saw sort of stateless, I was just like, it didn't make any sense because I haven't had that much experience with it, and that's what we're gonna get experience by building this application. Cacheable, just that's another one that is abstract. It means that certain requests can be saved to use later. So the response can be saved to use later. An example here, for instance, will be if I refresh this website, it's going to ask for that I had, right? If I so this word that performance. An image is a resource as well. A text for what we call resources. And in REST APIs, we reach those resources through an URL. And the dog let random people just add the dog picture. Right? He took that as a secure. Let me give a minute for that. up at some point. What else should we try in here with the post request? Yeah, here is the example that we were seeing. That unfortunately this database doesn't actually try to make a put request to update the title to foo and the title to bar and the body to foo. Make a put request, because a put request needs to update. You need to edit the entire data point and only modify the parts that you want. If you don't do that, you end up throwing away all the other data that you had, like the title and the user ID, and you get only what you specify in your put. So, in fact, put could also be used to create a resource like post. And in case that that put doesn't find that resource at this URL, it will create it. If it doesn't find the resource, it will create it. If you try to make a post to a URL that is, let's say, already post 1, the first post with ID 1, you should get an error. In this case, you probably don't get an error because this is a fake API. But if you try to create a new post and you give it a URL that already exists, you should get an error saying that that resource already exists, something like that. So yeah, for this, read that article that I posted on Slack. Delete, this one is pretty straightforward. We don't need a body, because what data do we want to add? We don't want to add any data. We just want to remove. So this one is similar to the get, but it should be used for deleting. It's similar in the sense that it doesn't body, and we can delete. We end up deleting the first post. So that's another one. Yeah, and then you will want to use these methods for their appropriate actions. Post for creating, put for updating completely, patch for updating partially, and delete for removing resources. Another thing that I wanted to make, a point that I wanted to make is, I forgot to mention earlier, is that HTTP is not the same as REST. HTTP is a protocol. It's how the information gets transmitted on a network. And CRUD is an architectural style that you sort of put into HTTP protocol to create APIs. So HTTP, completely different things. One is a protocol, which determines how the data is being transmitted and the communication. And the other one is an architectural style, how you define your API. The last thing that we need to do here is just talk about CRUD. And CRUD is